All right, hi everyone. Sorry about the delay there, some technical difficulties, but nice to see everyone here. My name is Hannah Arnson. I will be talking to you today about data science, the detectives of the future. A little bit about myself. I am a data scientist. I've been one for about 3.5 years at this point. My background is originally in neuroscience and math, and I decided that I was most passionate about really understanding how patterns worked and how we could identify patterns in complex data sets to solve problems. And that's what drew me into data science. So a little bit about where I work. I work with Pandata. We are a Cleveland, Ohio-based data science design and development firm. We empower innovative organizations to design and develop AI solutions. Our deep expertise in human behavior is why we shine at designing and developing ethical and approachable AI and machine learning solutions for innovative teams. And just an important fact to know about us is we like pandas. So today I'll be talking about some overview of what is data science. What do we mean when we talk about that? Some examples of data science in our lives, and then we'll get to do a fun hands-on data science activity. And at any point, if there are any questions, just throw them in the chat and hopefully we can have some conversations here. So what is data science? Data science exists at the intersection of math, statistics, computer programming, and business. Data science is the application of these tools to provide insight and value from data. Now, what does that mean to provide insight and value from data? Now, at its core, data science is about pattern recognition. This is something that people are really good at and that the human brain is really good at. For example, here are a bunch of dots. Can someone throw in the chat what they see? Do you just see some dots or do you see anything interesting here? Person walking, yeah. So it's not actually a person rocking, it's just a bunch of dots moving around, but our brain is really good at filling in these patterns. So really, this is what data science is. It's about using computers and math to identify these kinds of patterns and achieve the same kind of pattern recognition that we can do, but at a much larger and faster scale. And the benefit is to apply it to solve problems. So for example, let's say you're a data scientist and you are tasked with predicting the next viral video. What are some patterns that you would look for in identifying what would be a viral video? If you want to throw something in the chat. Maybe how many views or something about it being funny or having animals doing silly things. Those are what I look for, at least in a video. So then the goal would be to use math, statistics, computer programming to do the same kind of pattern recognition. And the power comes in really being able, current popular topics, good one. The power comes in being able to analyze many thousands of these videos automatically and really quickly leverage these kinds of patterns to identify the top contenders of this viral video. So to recap that process, it's really pattern recognition. Applying pattern recognition to answering a question and then automating the process so that you can do it repeatedly and quickly. Now, what does a data scientist do? A data science exists at the intersection of computer programming, so Python and R are the big programming languages used most frequently, math and statistics, and then the expertise in the domain or a business knowledge, so being able to apply the math and the statistics and the computer programming to solve problems. But ultimately, at its core, it's about detective work. It's about asking all the questions, asking the right questions, and really drilling down to understand what's going on. I'm going to talk a bit about some projects that I've been working on to make this a little more concrete. So one project that at Pandata we do as an internal kind of fun holiday project is a greeting card generator. And if you want to check it out, you can check it out at the website fun.pandata.com. We scraped about 4,000 holiday greeting cards from the internet, and then we use a kind of model called deep learning that's really good at identifying very complex patterns in things that are well, complicated, like image recognition or human speech recognition. So these models are able to identify what makes a holiday greeting, and then we can use that to generate some fun new messages. Some examples, it can be silly, so wishing you a merry holiday exhilaration. It can be completely nonsensical. It can be kind of interesting and just kind of funny. This is kind of a fun project that we work on as a way to just showcase the fun side of AI. A more serious, with much more practical applications project that I've been working on is in the realm of cybersecurity, looking at insider threat detection. So insider threat is a growing threat in cybersecurity where employees may be compromised or may be acting in with a bad actor and doing malicious things. So typically in cybersecurity, we have ways of blocking external threats. There's firewalls, there's rules of access and restrictions, things like that. But when an employee is working within an organization and has access to things they might be doing ways they shouldn't, that can be much more difficult to spot. So we've been working with a Fortune 500 utility company to develop a series of artificial intelligence algorithms to identify how people are behaving and if they're behaving abnormally or maliciously. We're using something called anomaly detection, where we're trying to characterize first what is normal behavior, looking at both where people go, so using their badging, when they badge into different places, what kind of digital behavior they're doing, what computers they're accessing, what servers they're accessing, and what kind of programs are running on those. At first, we were really good at being able to characterize what people typically do, their normal behavior, and then we found things that are abnormal. It turns out most abnormal behavior was things that are not malicious, which is good, but people coming to work late because traffic was bad or swapping shifts with a coworker, these kinds of things. So we asked a bunch more questions, and we ended up working with their cybersecurity analyst team to use feedback, human feedback, and use that to make the model that we built smarter and more in tune to identifying rare and potentially malicious behavior versus things that are just abnormal. And so now we have a system that is greatly reduced the number of false alarms and is trained to identify really the top most risky behaviors. Unfortunately, these things are rare, so it's not like we're catching tons of things, but the system is in place there. So that way, we are able to detect malicious behavior. Now, data science also exists in our everyday life. Things like your phone's virtual assistant, playlists on your music, Spotify, that are recommended, knowing when your packages are going to get delivered, some of the fun Zoom filters, which unfortunately I don't get to use enough at work, and predictive text, where you start typing something into a Google search and it pops up some recommendations to fill it in. And data science is also in the news, and sometimes it's really exciting things like image recognition. So this is a branch of data science that's capable of doing some really cool things, like it's technology underlying self-driving cars, unlocking your phone with your face, some breakthroughs in using AI for medical imaging and diagnoses. However, there are also some headlines in the news around data science that are more problematic. So you may be familiar with deepfakes. This is a technology where artificial intelligence is used to take videos of people and make it look like they're saying, or make them say things that the designer chooses. This can be fun. This is an example from the Samsung Artificial Intelligence Center, where they used AI to make Mona Lisa speak, which is, you can imagine, some fun, silly applications of that. But imagine if instead of Mona Lisa, this was a public figure or a politician, and you can make them say whatever you want. That could be potentially very problematic and lead to a lot of misinformation. There are also headlines about privacy concerns. So for example, this from last summer, a facial recognition software company was scraping images from the internet of which they had questionable rights to access. And so it's extremely important that data privacy is kept top of mind and that informed consent is gathered from people in sharing data, their personal data. And there are also a lot of unfortunate headlines about bias in artificial intelligence. And there are some examples here where facial recognition technology has led to some significant racially biased outcomes. And this can be extremely problematic and potentially cast some doubt on how artificial intelligence and data science are being used. And part of the reason underlying this is the way that artificial intelligence is used, how these models work. So we talked about these privacy concerns and biases. There are a couple different kinds. There's statistical bias, which is more of a mathematical concept, where your expected value and your actual value differ. So you can imagine a situation where you're measuring the average height of people. But let's say instead your sample was just basketball players. Now, in this scenario, the average height that you'd be getting is biased because it would be much higher than the average height of the general population. Now, social bias also exists, and this refers to unfair prejudice in favor of or against a group of people. And part of the reason this is such a big problem in artificial intelligence and data science is that if you think about what data science is pattern recognition. So if there are patterns in the data that lead to biases, then these will be propagated through unless there is some kind of mitigation. And unfortunately, humans are biased, so biased data in can lead to biased data out. Unfortunately, there are a lot of things that can be done to mitigate this. There's a whole slew of active research being done right now, and there are a bunch of different tools that we use that we can help mitigate bias. And the point of me bringing this up today isn't to say that data science is bad or biased entirely or doomed, but rather that this is something that needs to be kept top of mind when working on data science projects. Now, so far I've talked about some pretty big picture examples of data science in your life or things that I've worked on. But data science is something that we're really all doing, and it isn't something that has to be out of reach. To give you a couple examples, predicting outcomes, that is a fundamental part of data science, being able to predict what happens. This is something we do. So let's say you're going to your school sports game. You know that your team is better than the opponent's team just based on previous outcomes and scores. So you can predict what's going to happen at the end of the game. Some math that you do in school. I imagine many of you have learned average, median, etc. These are things that we do in data science all the time. The scientific method. Many of you have probably learned about this in school, but it's the idea of taking observations, asking questions, forming a hypothesis, doing experiments to test that hypothesis, often then changing your hypothesis and going back and doing more experiments, doing some analysis to figure out what's going on and drawing a conclusion. Now, this is the process that we follow all the time in data science. It's about asking those questions, questioning those questions, doing some experiments, questioning those experiments, doing analysis, and so on. Can anyone think of any other examples you can put in the chat, maybe? Things that you might do in your daily life that are data science or related to data science, or ways you use it. Any takers? All right. Predicting math answers. That's a good one. Exactly. We'll talk about algorithms in a minute, and a lot of what we do in math is algorithms. Oh. Actually, that's a great segue to this next slide where we talk about some key data science terms. So in a minute, we're going to do a hands-on data science example. Yes, identifying solutions to problems, calculating GPA, yeah, machine learning, like these are all predicting things. These are all exactly examples of data science and how we can do them in our everyday life. So some key terminology that is important going forward. An algorithm. So this is something I think I've used, word I've used a couple times so far. It's basically just a set of instructions or a recipe. In data science, this is a kind of complex set of rules or equations or programs that try to find these patterns, like looking at the virus behavior of COVID in different countries, good example. But a simple example of an algorithm is a recipe. So get bread, put peanut butter on bread, put jelly on bread, eat sandwich. That is an example of a recipe or an algorithm as well. And data, the next two terms refer to different kinds of data. So we have training data and testing data. When we develop an algorithm or a model, we typically, best practice is to take one set of data that you're doing all your experiments on, you're developing your algorithms, you're doing all the testing on originally. And then you have a separate set of data that the model has never seen. And this is used really to validate and make sure that your algorithm is not picking up on features that are really specific to that small data set and is much more generalizable. Because this can really make or break the success of a data science outcome. And I see a question in the chat. I will get to that. Let me just finish these, and then we can talk about the difference between modeling and data science. So feature selection, and we're going to be doing this in a minute, is identifying the relevant and necessary features of data. So data can be very complex and multifaceted. There are going to be things that are important and things that aren't. And part of the process is figuring out what is important and what isn't. And then the last two are different kinds of models or algorithms. Supervised learning, which is what we're going to be doing, where you have ground truth information. You have labeled, what's called label training data. And so an example of this is, let's say you're building a photo classifier that says if a picture has a cat in it or not. Let's say you have a set of maybe 100 pictures that have cats and 100 pictures that don't, and they're all labeled. It says cat, no cat, cat, no cat. You would use this small subset of data to train your model, to build your algorithm, and then you would have a general, and then you would generalize it with the goal of being able to identify cat or not cat, regardless of whether or not there was a label. In unsupervised learning, you don't have those ground truth information. You don't know if there's a cat in the picture or not. So an example of this might be you're taking your own personal photographs on your phone and you want to see what people are in there. So you can break it out. You can use these algorithms to find these inherent patterns in the images, and it would group, this person's face here, this person's face here. And then you can look at them and say, oh, that's the friend cluster, that's the mom cluster, that's the dad cluster, so on. And so that's an example of unsupervised learning where you don't have these predetermined labels. Now, before we dive into some actual algorithm building here, there's a question about what is the difference between modeling and data science? And that's a good question. Ultimately, it's just a matter of terminology. Modeling is part of data science, I would say. Data science involves building models, solving problems, things like that, but it also involves the application of these. So you can build a wonderful model, but if it doesn't have a good application to solve a problem, then it's not as useful. Right, so that the data science is really the connection between building these models and these algorithms and using them in a way that benefits people, benefits companies, solves problems, things like that. Yeah, keep the questions coming in the chat. What is data science in the first place? Well, so we talked about at the beginning, but I know there were some technical difficulties, so maybe not everyone got that, but really, data science is finding patterns and asking questions and trying to use these patterns to make informed decisions that you can use to get value out of. And so we can walk through an example here of a classifier. And let's do this one. I'll lead through this one together first, and then we will do one together. And you guys will really take the lead on that one. So here we are tasked with building a classifier of what is a pig? What is a pig? Is this picture a pig? Yes. So the first step is going to be some feature selection. So these are some things that I just came up with at the top of my head. The features of interest of a pig is the color, the ear shape, and the appendages that they have. So we can use this to generate some rules. So the rules we might come up with, let me go back, are the color is pink, the ear shape is pointy, and the appendages are 4 legs and a tail. And I think that pretty well describes these pictures of pigs right here. So based on these rules, is this a pig? It's pink, has pointy ears, has 4 legs and a tail. I would say yes, this is a pig. What about this one? It's pink. It has pointy ears. It has 4 legs and a tail. Oh, appendages are like body parts that stick out, so like arms and legs and tails, things like that. Would you say this is a pig? Based on the rules, yes, or the algorithm, yes. Based on what we know about pigs, yeah, maybe. It depends how we're characterizing this. I'm going to be generous and say it is a pig, because it's a piggy bank. It looks like a pig, at least. Now, what about this? Based on the algorithm, is it pink? Yeah, there's pink on it. Does it have pointy ears? Yep. Does it have 4 legs and a tail? Yep. So based on the algorithm, this is a pig. But based on the fact that we know that this is a horse, we would say the algorithm is wrong here. Okay, more color than just pink. That's fair. And so maybe the way we set this algorithm is overly restrictive. And ears and snouts, I guess those are technically appendages too. But what about these? Are these pink? No. Do they have pointy ears? Yeah, pointy enough. Does it have 4 legs and a tail? Yes. So based on the algorithm, you would say these are not pigs. But I happen to know that these are, in fact, pigs, just a different kind of pig. So in this example, how did we do? We got 2 right. We classified these as pigs. Let's be generous and say piggy bank counts. And the horse we got wrong, and these pigs we got wrong. So why didn't we get everything correct? Are there some rules that we should have done differently, or ways we could have changed them to make this a better algorithm? You want to put anything in the chat? Yeah, 57% correct. Weight, so maybe the weight or the size. Okay, so that could have ruled out the horse. Yeah, we do need better if-then rules. That's fair. Snout size, that could have ruled out the horse for sure. And probably include the pig. Add more features, absolutely. Allow more colors. I think that's an important one because we only had these 3 pictures of pigs. If we go back, these are the only pictures we had to form these rules. Let's pretend we didn't know what a pig was and we just saw these. That's how we based this off of. So this emphasizes the point. We need more than just a couple examples of training data, or else we get into these biases where we only know that pigs are pink. Yeah, maybe ignore clothes and coins. That's absolutely, these are great ideas. And sometimes building these kinds of classifiers can actually be pretty tricky. If you haven't seen these yet, I would highly recommend you Google this. There are about 15 of them maybe, and they're really funny. This first one is loaf of bread or a corgi butt. And some of them are hard to tell if you look quickly. And this one is chihuahua or blueberry muffin. You can imagine that if a person has difficulty figuring this out, sometimes it might be very complicated for a machine. So with that, it gets time for us to make our own classifier here. So typically when I've done this before, I've been able to move everyone into breakout rooms and do this in smaller groups. But since I don't think we can do that in this forum, then we're going to just be creative and do this together. So keep using the chat. Thank you for that. So the way we're going to do this is we're going to go through the same process. We're going to start with feature selection. We're going to do some documentation, write down our observations. We're going to do some algorithm design, and we're going to test the algorithm, and then we're going to compare and discuss. And try to find those friendly monsters. So I'm going to switch to another sheet here. Can everyone see some friendly monsters? If someone could just put yes in the chat so I know that you all can see this. If you can see the monsters in a Google sheet. Okay, thank you. All right, so what we have here is our training data. We have 6 monsters. The 3 in this column are friendly, the 3 in this column are not friendly. Our goal here is to identify A set of rules or an algorithm that lets us predict if the monster is or is not friendly. So first step is feature selection. So can some people put in the chat, what are some features before we get into what relates to friendly and not friendly? Just, what are the color, like is shape, is size, things like that. What are some features we want to put in? So smiles or not? Color? Spikes? Spots? Shape? Any other features? Number of legs? Number of eyes? We have spots, yeah. Any other? Number of limbs? Mouth shape? All right, teeth. All right, I'm running out of space. So let's how about that? I think that's a good list. Any others that we should include? Oh, number of arms, that's good. Here, I can squish these a little bit. Number of arms, okay. We have eyes, yeah, we have that already. All right, so is this a good list of features that we can use to break these down and try to characterize the different monsters based on these features? All right, well, let's go with this for now. So how about we start with monster 1 and we go across and we fill in yes or no. Does it have these things, or number, whatever the answer is. So monster 1, smiling or not? And so this is monster 1 right here. So I would say no. Color, I can say green. Spikes or no spikes? I see a lot of greens. Do you think these pink things up there count as spikes? Yeah, okay. All right, does it have spots? All right, how would you describe this shape? In my mind, it kind of shaped like a tooth. Yeah, okay, let's go with tooth shaped. Great, number of legs. Are we counting just legs, right? Because we have number of, or should we change number of limbs maybe to number of arms to make that, so we can characterize both? How about that? Okay. Number of legs, we got 2. Number of eyes, got 2. Number of arms, we also have 2. Mouth shape. Is that, I don't know, yelling maybe? Kind of looks like it's yelling. Rectangle, that works. All right, it has teeth. It has what, maybe 8 teeth or something? Let's just say that. And okay, number of arms is on here twice, so we can cut that one. Razor teeth, I like that. Although I think they all have razor teeth, right? All right, how about monster 2, this blue guy right here? Smiling, I would say not. Color, 2. Spikes, no spikes. Spots, Yes, spots. Shape. Someone wrote tongue. I like that, but I think we called the last one tooth, and they're the same. So let's go with tooth. All right, number of legs, we have 2. Number of eyes, 2. Number of arms, we have 2. Mouth shape, and number of teeth, 3. All right, so get the idea. I can start to fill these in. So number 3, that looks pretty smiley, right? That's this little green guy right here. Color is green. I would say he has spikes, spots. Yep, spots. Teeth. Yes. Oh, shape. How would you describe this shape? Maybe, to me, it looks like an alien. King of the world shape, duck beak. Okay. How about duck, shorter, duck, beak, alien? We know what that means. Okay, number of legs, we got 2. We got only 1 eye. 0 arms. Its shape is a line, would you say? I don't know Monsters University. A regular shape, yeah, that's good too. Let's say what, 2 teeth there, 2 little pointy teeth. All right, now number 4 is pretty similar, but it doesn't have dots. So it's smiling, it's green, it has spikes, oops. It has no spots, shorter duck beak alien, 2 legs, 1 eye, 0 arms, it has a line mouth, and 2 teeth. All right, what about number 5? It looks like it's smiling, I think. Yes. Color is green, spikes, it has spots. What would you call this shape? Frog, yeah, that's good. It has 2 legs. Do you think this has 1 eye, 2 eyes, or 1.5 eyes? You mean 2 eyes? All right, let's get 1 or 2 more opinions. Okay. We got 2, some 1s, 1.5. How about we go with 1.5 because that's the average of what everyone's saying. And as data scientists, we like to take averages. So let's do that. All right, number of arms, 2. Mouth shape. Like a semicircle, maybe. Let's do that. Triangle, yeah, that's probably better. Okay. And it has 2 teeth. All right, and this last one, I think that's smiling. It looks like a happy pink thing to me. Yes, it is smiling. It is pink. It has spikes. It has spots. Shape. Any thoughts on the shape? Malformed tyrannosaur. Okay, let's go with dinosaur. Yeah. It has 2 legs. It has, I guess if we went with 1.5 eyes for number 5, let's go with 1.5 eyes for this. It has 0 arms. How would you describe the mouth shape? Maybe that semicircle? Half, okay. Half moon. And it has 3 teeth. All right, so now that we filled out all of the features and we documented them, let's look at the labels. So this is label here. Okay, sorry. We know that numbers 1, 3, and 5 are friendly. Friendly. Friendly and not. All right, so now we can start to look at how these break down. What are some characteristics that we really only see with the friendly monsters? And we can go, let's go column by column. So smiles, does that seem to correspond to whether or not the monster's friendly? It looks like we have a no for a friendly and we have a yes for a friendly. So looks like smiles, does smiles count for friendliness? Okay, so no. Yeah. So you cannot judge a monster by whether or not it smiles. What about the color? We have friendly, that's green, not friendly, friendly, that's green, friendly, that's green. So it looks like green seems to be all friendly monsters are green, but there are some not friendly monsters that are green too. So maybe we keep green as part of it. So green. And it's not the only thing, but that might be part of it. So it has to be green. Let's see, what about spikes or no spikes? Looks like the 3 friendly guys have spikes. And the 3 friendly guys have spots. So green, spikes, spots. Let's see, does the shape seem to matter? We have a friendly tooth, a friendly shorter duckbeak alien, and a friendly frog. So that doesn't seem to matter. Number of legs, they all have 2 legs. Number of eyes, does that matter if it's friendly or not? We have a friendly with 1, a friendly with 2, and a friendly with 1.5, so I guess not. What about number of arms? We have a friendly with 2 arms, a friendly with 0, and then a friendly with 2 arms as well, so yep, no. And mouth shape, we have a rectangle, a line, and a triangle. Number of teeth, we have 8, we have 2, and we have 2. All right, so we have our algorithm here that it's green, it has spikes, and it has spots. Now, if we look back at these, are we good with this? All right, so let's call this our algorithm, right? To be a friendly monster, it has to be green, have spikes, and have spots. So now let's go to our testing data and see how we do. So here's a whole bunch of monsters that we haven't seen before. And let's see how our algorithm does. So monster 1, it's green, it has spikes, and it has spots. So is that friendly? Based on the algorithm, I think it would be friendly, right? Yep, yes. Okay, friendly. Okay, monster number 2, we said it had to be green. So that guy is a mean monster. Number 3, it's not green. All right, what about number 4? It's green, it has spikes, but no spots. So we're going to say not. Now what about 5? It has spots, it's green, it has spikes. So let's say it's friendly. All right, I see in there the numbers 1, 5, and 8 are friendly. So let's go with that. And 6 has no spots, 7 is not green, and 9 is not green. So all right, let's see how we did. So now we can go look at the results. And we did really well. So this is the prediction, and these are the actual data. So this is, since this is our training data set, or our testing data set, we have labels, we know the correct answer, and we can look. We found that they're friendly. Number 1 is friendly. Number 5 is not friendly, or is friendly, and number 8 is friendly, and the rest are not. So we got all of them correct for 100% accuracy. So that is awesome teamwork. Since we got started a little bit late, we didn't get to do, well, how about we quickly go through this next one? I think we have a few more minutes. I just want to make sure we have some time for questions. This next one is a different set of monsters. And so here the goal is to identify a different algorithm. And since it's a slightly different, I'll just spoil it for you. Since it's a slightly different set of monsters, they actually have slightly different features that you can identify as friendly and not friendly. So if you hadn't seen that other group before and you just saw these, you might come up with a different rule. And that different rule can lead to having your accuracy be worse. And so this is supposed to be an example of how a small data set can be problematic, how bias in data can come out with these really small data sets as well. But we don't have time to go through all of that today, unfortunately. And then there was another one where we have a whole bunch of them that we would come together and do. But yes, any thoughts about how we did on the monster classifier? So what do you do when things are more complex and traits are different in relation to each other? Yeah, so in the real world, that is often how it is. It's not as clear as they have polka dots or they have spikes or they're different colors. It is complex patterns that a human may or may not be able to pick out on. And that's part of what data science algorithms are really good at identifying. So they identify, like, instead of a person saying, these are the patterns that I see, the mathematics can find these are the dimensions that are most different from each other. And so that can lead to much more complex features that are really hard to just tangibly describe, like polka dots or color. What are some thoughts about how we did perfect performance, so that's maybe not the best question, but had we done this, had we had more time and then we would have seen that we might not have had perfect performance in one of the other examples. So any thoughts about ways that we can improve this? Or it was actually just good, so. Well, hopefully that was a fun exercise. Just to recap a couple things, how do you become a data scientist? Hopefully some people here today are thinking about maybe one day becoming a data scientist. And if you have any questions about that, please ask in the chat, or you can contact me after. But really it comes down to things like these, like asking questions. Ask all the questions. Learn programming languages. Python is the most commonly used right now. Math and statistics are so important. Practice. So there's something called Kaggle. If you are curious about data science, you can check it out. It's these like data science questions that you can kind of compete in, and you don't necessarily have to compete. You can just solve the problems. But it's a good way to just play around with data and see what other people did and learn from that. Hackathons they're often local, or colleges do a lot of that, where you get together with a bunch of people, you form teams, and you try to solve a problem, like a data problem. Like, how can we, improve world hunger using data science, things like that. These really giant goals, but you get together and you spend 24 hours working on it, and they're pretty fun. I don't know if they have those at the high school level, but you don't actually hack a computer. It's hacking an idea, kind of, is the idea behind it. So you just do data science as a group to try to solve a problem. And communication is so important in data science. You can build the best model that has the biggest impact, but if you can't communicate it to the business folks or the people who are non-technical but need to be able to understand it, then it won't go anywhere. So some take-homes from today. Data science, it's not magic. It's not these black box things. It's pattern recognition. Human interpretability and human flaws are passed through data science and so are extremely important to be mindful of. It's important how to govern how we vet and how we think about data and consider all of the consequences, either obvious consequences and also the unintended consequences. And this might be my personal bias, but I think that data science is a great job. So I'd like to take any questions. Yeah, Highland does have a hackathon for high school students, and actually we are putting on a camp about data science with Highland this summer. So, oh, I know you. Okay. So anyway, please reach out if you have any questions. You can email me. You can find me on LinkedIn. I will put my email in the chat here too. Any other questions? Will we still have a couple minutes here? Well, thanks. It's been great to virtually talk to you all. If anyone is interested in finding out more, anything like that, just let me know. And stay away from mean monsters.